Electrons. By the end of the 19th century, physics included all of the following: Newtonian mechanics, Maxwell's equations, which unified the ideas of electricity and magnetism, thermodynamics, which linked heat and work. The speed of light had been measured, and no stationary reference frame had been found. This, of course, eventually led to Einstein's special theory of relativity in the early part of the 20th century. Many physicists were comfortable that nearly everything had been discovered, but then some mysterious things began to happen. About 150 years ago, cathode rays were discovered. No one knew what they were. Physicists working on the problem just knew what they could see. And what they saw was that when a high voltage was applied between two metal plates inside an evacuated glass tube, a shadow was cast on the glass behind the positive plate, and the glass surrounding the shadow glowed. The glow was enhanced when glass was treated with fluorescent chemicals. The observed shadow and glow implied that something was traveling in a straight line from the negative plate, the cathode, towards the positive plate, the anode. The positive plate stopped some of it, that created the shadow, and when it didn't stop, created the surrounding glow. Since the rays seemed to come from the cathode, they were called cathode rays. You can have a look at the site below for a demonstration of the cathode ray tube, complete with the metal cross. When we look at the cathode ray tube, we see the shadow, we see the glow. Hey, could it be light? Light casts a shadow. Or is it something else? Is it some kind of invisible particle? How could you check to see if it was some kind of a particle and if those particles were charged? Think about this for a moment and then go on to the next slide. You might have recalled from earlier units on electricity and magnetism that one way to see if you might be dealing with a charged particle is to apply an electric field across its path. If it is charged, it'll be deflected. If it's something else, for example, an electromagnetic wave like light, it won't be. Also, the direction of deflection will tell you whether it's a positive charge or a negative charge.